I can demonstrate merge sort to you if you like. So for that I have got another prop. We bring in this. So I'll deal out 7 cards. For merge sort we split the list into 2 parts. Okay, so we've got this left half goes there and the right half goes there. So we've got 2 lists now. This list gets split into 2, this list gets split into 2, and then each of these 4 lists gets split into 2 until you've got either 1 card or no cards in your list. Now what we do, we look at each of these pairs of sorted lists and we merge them back together in the right order by looking at the top card on each list. So first of all we put 4 and then we put 7. Okay, so now that's a sorted list there. Okay, so with 10 and 8, we look at the lowest card, put that in first, we've got 8, and then we've got 10. And then with this one we've got 5, and then we've got 7. With these 2, we've got 3 and the empty list, so 3 just goes there. Hopefully everyone will agree that a list with just 1 card in it is sorted. I've separated them just for clarity so you can see the cards. You should only be able to look at the top element of each list. So now what we do, we merge these 2 sub-lists back together. Which is the lowest card between 4 and 8? Those are the only 2 we can see. So we pick 4, that goes in that list. And then we say which is lowest between 7 and 8? It's 7. Which is lowest between 8 and nothing? It's 8. And then similarly with 10 and nothing, it's 10. And then we look at these 2 lists, we pick the lowest, so we've got 3. And then we've got an empty list, so we just put 5 there and 7 there. So we've got 2 sorted lists now, and all we do is merge them back together. So we've got 4 here and 3 here. So 3 is lowest, so that goes first. Between 4 and 5, 5 and 7, and 7 and 7. Between 7 and 8 is 7, 8 and nothing it's 8, and then between 10 and nothing it's 10. I did 3 tests. We've got bubble sorts, we've got the slightly better bubble sort, which is the one where you check less elements each time because you know the highest ones are already sorted. So we can see that actually around the low end, merge sort can be significantly slower than either bubble sorts. And that's because merge sort's got slightly more overhead associated with it, and also I guess the lists are more likely to be sorted or nearer sorted when they're smaller. So we've got the input size here, so I sorted 10 things in this row. I ran it 1,000 times for each, so 1,000 different randomly sorted lists. So it took 391 nanoseconds to sort 10 things with the first bubble sort, 322 with the second bubble sort, and 770 with merge sort. Even though merge sort should be quicker, there's going to be a little bit of overheads. It's a slightly more complicated sorting algorithm. However, as the input size gets bigger, if we get to 100 say, bubble sort took 28,000 nanoseconds. The better bubble sort took 19 microseconds, and merge sort took about 8 microseconds. So you can see there that the merge sort's already starting to take over, even by 100. So let's see what it's like at 1,000. Bubble sort is taking 3 milliseconds to sort a list of 1,000 things. The better bubble sort is taking 2 milliseconds, and merge sort is taking 0.1 of a millisecond to sort the list. With a small n, it doesn't really make much difference, but with a big n, it makes a world of difference. It's really important. Okay, so at 5,000, it was taking 77 milliseconds to sort with bubble sort, 51 milliseconds to sort with a better bubble sort, 0.65 of a millisecond to do merge sort. Bubble sort, as I said earlier, scales with the square of the input size. So we're going to call the input size n. So we can say bubble sort scales with n squared. Merge sort that we've just done, that scales with the input size times the log of the input size. A log is just the inverse of a power. So if you've got 10 to the power of 3, say, is 1,000, log to the base 10 of 1,000 is 3. Whatever the base of the log is, it's just a constant factor in front of it, and that doesn't matter. Merge sort will always take n times log n runtime. So in the best case and the worst case and the average case. You've always got to split the list into 2, and into 2 again, and into 2 again, and then you've still got to compare them all and merge them back together. So that one, that one, that one, that one. So you've kind of always got to do the same number of steps. The best case of merge sort is still n log n, whereas bubble sort, what you'll find is if you've got a list that's already sorted, it will only take n steps to do it, because all it's doing is goes, do I need to swap these? No. Do I need to swap these? No. Do I need to swap these? No. Okay, so you've done basically n steps, so it's proportional to the number of cards. You don't need to do any swaps, so you're done. But if you want to sort a list with 1 million things in, bubble sort's not the way to go.